I am Neeta Sharma from PM Expert. In this video, we will build an intuitive visual understanding of the normal distribution, also called the bell curve. We will see what the shape means, what the parameters mu and sigma do, and how the empirical rule helps estimate probabilities quickly. Here is the classic bell shape of the standard normal curve. The peak is at the mean, which we call mu, and the spread is controlled by sigma, the standard deviation. We will mark mu at 0 here. Next, we mark 1 sigma, 2 sigma, and 3 sigma to the left and right. The empirical rule says approximate percentages of the data lie within fixed numbers of sigma from mu. About 68% lies within 1 sigma, about 95% lies within 2 sigma, and about 99.7% lies within 3 sigma. Two parameters define a normal distribution. Mu is the center. Sigma is the spread. We often standardize using a z-score. Z equals x minus mu all over sigma. This converts any normal problem to the standard normal scale. Let us solve a quick example using the empirical rule. Assume x is normally distributed with mu equal to 100 and sigma equal to 15. We want the probability that x lies between 85 and 115. We draw the bell curve centered at 100 with that spread, then shade from 85 to 115. Because this interval is mu minus 1 sigma to mu plus 1 sigma, the empirical rule says about 68%. Another fast estimate. What is the probability that x is less than or equal to 130? We bring the same curve back in view. We shade from the far left up to 130. 130 is mu plus 2 sigma, so the empirical rule gives about 97.5% to the left. Finally, see how mu and sigma change the curve. A larger sigma makes a flatter, wider curve. A smaller sigma makes a taller, narrower curve. Changing mu simply shifts the curve left or right. To summarize, the normal curve is centered at mu and spread by sigma. Using the empirical rule, about 68% is within 1 sigma, 95% within 2 sigma, and 99.7% within 3 sigma. These quick estimates help you reason about probabilities without a calculator.